Alright guys, so here we have the code to the Arduino. So I may also do a Raspberry Pi version of this as well, but this is how we're going to do it through the Arduino. So it's using just a basic Ethernet shield. I'm not going to lie, this code is actually mainly, I got most of it off the internet. It was to control LEDs through a web browser, and I kind of modified it for our purposes here. Just because it's been a while since I've written code for Ethernet shields, and I'm a little rusty on it. But so this is a sort of my revised version of an LED code modified to run for a garage door opener. So let's go ahead and take a look at it. We'll run through it real quick, and we'll upload it to the board and see how it works. So I'm just going to kind of explain everything. So first off, of course, we're including just the basic stuff, the SPI and the Ethernet. Those are just the the .h files for the libraries to make things work right, so that it works with those shields. So then we also have the control pin here. So this control pin, pin 6, this is actually the pin that we are using to control the garage door opener. This is the one that's going to drive that transistor, right, that I showed you guys in the schematic in the last video. So that is going to go to the gate of the transistor. And I might actually use, instead of a MOSFET, I might end up using a bipolar transistor. I'll see what I have laying around handy, so that'll be in the next video. But either way, this pin 6 is going to drive it. So I decided to add a feedback pin. This is on pin 36. Now we are using an Arduino Mega here, so that's how we have such a high pin number, 36. The Mega has, like, I don't know, 40 or 50 something pins or something like that. Ridiculous number of pins. So why I chose 36, I don't know. It was just like the first one I saw on the board, and I was like, hey, let's use 36. So anyways, that's the feedback pin. Now this is actually gonna kind of get the actual state of the garage in real time. You do this several ways using, say, like limit switches or whatever, and say, okay, if this limit switch is hit, detect that the garage is open or detect that the garage is closed. That's what we're doing with this pin here. We'll get in a little bit more into that in the actually setting it up and wiring up the Arduino in the next video, but I just want to kind of explain what that is. And then so here we just have these blank strings of set, post and set. We're just declaring them. They're just blank right now. And then we have our MAC address, our IP address, gateway, and subnet for our Ethernet shield, and then we're declaring that it's going to start up on port 80. So if you guys don't know how to set this is going to be specific to your actual network. If you guys have seen the rest of my videos, and you know this is sort of following my network I don't know, setup. 10.0.0.120, my gateway is 10.0.0.1, and subnet is 255.255.0.0. So that's how my network is configured. It will definitely probably most likely be different on your network. Anyways, so then here we have the setup. So in the setup, we're just starting the Ethernet shield. We're Ethernet.begin, and then we put all these variables in there so it knows what to start up with, and that's the server.begin. So that's our server running on port 80 through the web browser. And then basically, we're declaring that, okay, pin mode, the control pin is an output. That's what's driving that transistor, remember? And then the pin mode for the feedback pin is an input. So it's reading that as a digital input, and this is a digital output. So then we have the digital write. So what we're saying is the control pin. This is the pin to control the Arduino. When the board is first started up, or if it's rebooted or whatever, we start the pin low. We do not start it high, because that could potentially open up the garage door at an unwanted time if we didn't do this. So we always want to declare the pin to start off low. That'll keep that pin low till we tell it to go high. Okay, so then we have this loop here. Basically, I mean, this is just basic Ethernet shield code. A lot of this, like I said, I got off the internet, but this is basically just waiting for a client, waiting for someone to connect through a web browser. And then you have this variable, this boolean current line is blank. That basically just detects if you've already hit the web page or not, and will send HTML content to the web page if you have not visited the page yet or not, or if certain content has not loaded. If this is set to true, I believe it sends information to your web browser, and if it's set to false, then it will not resend that information. It just keeps the form from looping through, because this is a loop here. So if we had this as a loop, it would detect your computer contacting the Ethernet shield, and it would send HTML information to it, to that web browser. And if it didn't stop that loop, if it didn't have this boolean to stop it, then it would just keep re-looping and just sending you more and more HTML information, and your page would overload. So that's what this does, is it just makes sure that it only runs once. So while you are connected to the Ethernet shield, we're just reading for the char C, that's for the URL bar. Basically, this is all just a bunch of stuff just to see sort of where the page is on the server. So if we connect to it, it detects that we're connecting to it, and it sends that HTML information. So this is all the HTML down here. Let me just show you guys this. It looks like a bunch of mumble jumble. It's all comments, kind of. It's not really comments, but it's all text. It's sending it as text, and it's printing this to the screen, and then your web browser interprets it as HTML because we're using HTML tags in here. For those of you guys who aren't really familiar with HTML, then this is not going to be, you're not going to kind of understand this, but here's what it was. It was Jack's LED controller. I got this off the internet from that and kind of modified it to work for my purpose here. But yeah, this is all HTML. And so basically what we have here is, normally it would trigger and you'd be able to turn the LED on and off. So what we've done is, instead of doing that, we have this door open. We have the doors. We have these radio buttons down here, and when you click them, it posts information to the page. You can see that we have this little JavaScript function here, and it submits the form. This is all a form here in HTML, and it submits the value. The value is going to be either open or close, okay? So that when we submit this form, when you click those radio buttons, the radio buttons will submit that information, whether it's open or closed. So then if we post it, post is a method of sending information through forms in HTML. If you guys are not familiar with that, again, this is all kind of web code here. This is more like for web design. But so then we have, if the post is equal to door open. So this means these both here are named door, so it can either equal open or closed. So we're saying if you click the radio button that says open, what we're going to do is we're going to see if the door state is false. This makes sure that the door is not already open, or I'm sorry, not already. Yeah, this is making sure that the door is not already open, so that when we click the open button, it digital writes that control pin high for 500 milliseconds. So we digital write it high, we wait 500 milliseconds, and then we turn it back to low. So this is how we are pulsing that pin 6 for half a second, simulating that button press. So when we push that radio button that says open, we are going to see the state of the switch. This is that, like I said, that limit switch that detects if the garage is open or not. Why do we have this? Do we need it? No, we do not need this for it to work. But what this does is it ensures that, hey, if the door is already open and I push the button that says open, don't still send this signal, because if we send this signal and we push the open button, it's just going to close it. It's going to close the garage door, and really we want to open it. We think we're opening it. And if we're away from home, there's no way for us to tell. So what we end up doing is we have a switch to see, okay, is the garage actually open or closed right now? If it's already open and I push the button open, then don't do anything. So if it's if we push the button open and it's closed, if this state is off, it's false, it's closed, the garage is already closed, then what we're going to do is we're going to open it. We're going to open the garage door. And then we have the same thing down here. If we push the radio button that says close, and we're going to detect that the door is actually open, to make sure it's already open, then we'll send this same pulse again to close the garage door opener. We'll pulse that transistor for half a second, and then it'll close the garage door. And this also ensures that the garage door is actually closed. It's going to make sure that we're not, if we push the close button and the garage is already closed, we're not going to send that command. And if it's open, then we will send that command. So that makes sure that we do not send commands that we don't want to at certain times. We make sure that the door is in the correct state. So that's just done with a simple button or switch or whatever to detect the actual physical state of the garage door, not what you think it is or what it should be, because there's no, the commands to open and close the garage door are exactly the same. You're just pulsing that pin for half a second. So we want to ensure the state of the garage door opener, and that's what we're doing with that feedback on pin 36. And by the way, so up here we say that the door state is equal to the digital read of the feedback pin 36. So door state is the state of pin 36, whether it's on or off, true or false. And then what we do is we can have this thing called set, this variable called set to open, and then when we if set is equal to open, then we change the radio button so that it's automatically selected, so that when the page refreshes, the radio button that we just clicked stays selected. And I'll show this to you guys in action in the next video when we actually run this. I'll show you what all this does. But then anyways, also another thing that it does, and this is that changes that variable to make sure that we do not send information more than once. But another thing that it does is when we enter the web page, it'll tell us based on the door state. If the door state is true, then the garage is open. If the door state is not true, else the garage is closed, and it prints this out on the screen, so that when we visit the web page, before we click either open or close or anything, we can actually just visit the web page and tell if our garage is already open or closed based on the state of that switch. So we can tell if our garage is already open. So if we go to the web page and we're looking to open our garage, it'll tell us, hey, your garage is currently open or your garage is currently closed. That lets us know the current state of the garage. So we'll go ahead and upload this to our Arduino. It may make no sense whatsoever. I will post this code probably somewhere on my forums or whatever, and I'll put a link down in the description of this video so that you guys can grab this code and modify it to your needs or whatever, do whatever you want with it. It's actually not very complex code, but yeah, I'll make this available for you guys so you guys can just download it or whatever, and we'll go ahead and in the next video it'll make a little bit more sense how this all works, and we'll actually hook this up. We'll download this code straight to the Arduino Mega and run this code and hook it up to the garage door opener. We'll integrate the Arduino with the garage door opener. So hope you guys enjoyed this one, and see you guys in the next part.